Welcome to this video on Model of Mechanical Translational System Basic Elements. The electrical, mechanical, and electromechanical equipment consists of moving parts. Some of them will move in a straight line, and some of them will rotate. The system having linear motion along a straight line is called a mechanical translational system. And the system which has rotary motion is called a mechanical rotational system. If we have the transfer function of a system, we can predetermine its output for a specific input. To determine the transfer function, we need to model the system. This video will explain how to model a mechanical translational system. Quantify the opposing forces acting on the system. We all are familiar with the bicycle pump. Its piston will move along a straight line within a cylinder to fill the air in the wheel. Hence, it is a mechanical translational system. Here, the force which we give on the handle is input. Let us denote it with F. This input force should move the piston for a certain distance by overcoming the opposing forces such as the mass of the piston, frictional force, and elasticity of the spring. The distance traveled, or displacement of the piston, is the output. Let us denote it with X. We can represent the opposing frictional force by a dashpot. B is the viscous friction coefficient. We can represent the opposing force offered by the elasticity with the spring. Here, K is the stiffness of the spring. Let us take the reference surface and mass of the piston. F, the input force, will act on the piston. It creates displacement, X. Since the dashpot and spring oppose the input force, we can connect them between the mass and the reference surface. Now, let us quantify the opposing forces offered by the mass, dashpot, and spring. The opposing force Fm offered by the mass is directly proportional to the acceleration d square x divided by dt square. We can remove the proportionality by adding the mass, m, to the right-hand side of the equation. The opposing force Fb offered by the dashpot is directly proportional to the velocity, dx divided by dt. We can remove the proportionality by adding the viscous friction coefficient, b, to the right-hand side of the equation. The opposing force, Fk, offered by the spring is directly proportional to the displacement, x. We can remove the proportionality by adding the stiffness of the spring, K, to the right-hand side of the equation. This brings us to the end of this video. We hope you can now draw the model of the mechanical translational system and quantify the opposing forces acting on the system.